Hello everybody, in today's tutorial we are going to be modeling project by Big called 79B and Park. This is a project that is located in Stockholm in Sweden, and we're gonna go through a definition that we created based on the input data, and as you can see here in the diagrams, you can see how the base plan of the building looks like, and it consists of squares which are rotated 45 degrees, and then we have the outline of the building, and this is the site of the building, which is supposed to be like a fusion with the park that's nearby. So that's the concept of the whole project. And you can see here that based on the daylight or the sunlight, these cubes are actually being risen above, and you can see here that the top corner was the tallest. So how do we achieve this in Grasshopper? Now we're going to talk about this. I'm going to walk you through the definition and how you can achieve this effect quite easily. So as you may know, I imported this image and I will lock it here in place, and we're gonna use this as a reference, and I'll just guide you through the whole process of creation. So let's start. First thing we're going to do, we're going to create one simple rectangle here. So we're using rectangle component, and we're simply creating that rectangle there, and you can see here that this is controlling the size of the rectangle, and here we get the output this as the same. So this is our rectangle, the initial one. The next step would be to multiply this rectangle in both X and Y directions. Once we multiply them, we'll have like a big grid all over here. And then what we're going to do, we're going to use simple techniques to create borders around that and inside. And then you will use call pattern to say which areas we want to keep and which areas we want to keep out. And then we'll use simple attractor curve to create our lines, and using extrusion in Z direction. So that's the concept. So let's start. So first thing here, what we're gonna do, we're gonna rotate this rectangle 45 degrees. So that's what this component does. However, this is actually what we want to achieve, and here is the angle, and you can, for example, change here the angle, and you will see that the angle will rotate 60 degrees. However, you need to pay attention to this area here. You need to keep the degrees on, because if you don't, then this will not be 60 or it will not be 45 degrees, as this is the amount in radians. So you either need to use this radians component to put 45 and put here the degrees if you want to have 45, or you can delete it and just keep the original degrees here, and that way you will have the rotation. All right, so let's turn off the guide that we don't need anymore. So now the next thing would be to create the grid. We need to create the grid in this direction and in this direction. So this area here is just going to give us the length. So let me quickly show you here what we're doing. So this is going to be X direction, and this is going to be Y direction, and we want to multiply this guy like this multiple times. So this area here is simply allowing us to find the middle point of this rectangle. That's what we use this component for. And then we want to measure this distance from here to there. Let me just show you. We want to measure this distance, and we want to multiply it 2 times to be until here. That's our goal. So that's why we use deconstruct brep here to be able to select this line here. And then we use list item to select the line. So let me just show you what this means. If you preview this guy, and if you preview this guy, you will see here that the list item is turned on to 1. So this means that, for example, if I change this to, let's say, 0, I will have a different point, and I have 4 total. You can see here that I have four total. 0, 1, 2, 3. That's 4 total. So in this case, we want to keep 1, the first one, and we want also to keep the middle point. So what we're doing here, we're creating one line from this middle point to this point, and then we're using length to evaluate the length of this curve, which means that this component will give us the length, which is this amount. And then the last thing is just to use it 2 times, multiply it, so we get this distance from center to center. That's the distance we need so that we can have a good grid. So that's why we have here multiplication, and the final result will be this number times 2. And that's what we got here. So we got that distance. And why did we use this distance? So we use this distance to be able to move it with the vector. So let's see what this means. This means, for example, when we use move here and we use x direction, because we said we're going to move it in the x direction, we need to use a component called series, which will give us some numbers from, for example, from 0, and that's where you give it at the start, from 0 until 24, and that's controlled here, 25. So that's basically the amount that you want to grow your grid. So for example, if I put this to 20, you will notice that the grid will lower down like this. See? So it was 25 because that's big enough so that we can manipulate the geometry later on. So let's see what's next. And as I said, this is the step. So the step value is, for example, we have this one. Let me just delete this real quick. So we have this one rectangle, and the step is pretty much like from this point how much you want to move it until you create the next one. And that's why we evaluated this result here, so that we have this length. If we put this to something else, for example, if you put this to 1, then this will be different. So then it will be, the grid will be like this, because it will just be 1. So let me just show you what this means. So now we have the step as 131, 1.131, and that's exactly what we evaluated here. So if you put here 1, let me show you what will happen. You see? So we don't get this distance correct. So you can see that they are intersecting, and that means that if you don't want to do this, then that's why you need this number. So that's why we use this number to create equal distances, and then that's why we're using it here. So once we multiply this in x direction, then we need to multiply it also in the y direction. So let me just hide all of this. And we're simply using move command again. However, this time we need to use this cross-reference component so that we get this grid nice and easy. If we don't use this, then we're gonna get something that looks like this. You're gonna get the first row only, and then you're gonna get only the elements that are going until here. So let me quickly show you what it is. So for example, if I undo this and if I just go like this is what will happen. So in order to fix this, you need to use cross-reference, and that way the data is correct. So let's go again, and there it is. We have our grid. Once we have our grid, we're gonna move on, and we're going to find first the centers of these rectangles. We use the area component for that. So from here on out, we're simply using like these elements here, from here to here, are going to be attractors. So this is attractor, and this is going to, and this is this part of the definition is simply going to be used to manipulate the extrusion of these rectangles. So let's see how we do this. So in order to do this, we need to give some curves. So in this case, we have one curve here, and it's 3D curve. It's curve in space. It's not simple curve on the ground. And we use also a curve closest point. And what this does is it gives you the closest points on this curve based on these centers below. That's why we have here the points. So for example, point number 1, like this point, is probably the closest to the curve, and there is some point that represents it somewhere around here. So that's what this does. And now this component is called distance, and it's simply giving us the distances from these points. So for example, from point let's say 0, and from point on the curve that is closest to it, it's giving us the distances. So it's saying, for example, what this does is imagine that this is one curve, and this is one point, and then this is the second point, and then this distance component is giving us the distance from here until there. It's giving us this distance, and it does this for every single point. And we're going to be using this component in order to remap these numbers and have a very smooth transition for the extrusion. So let's see how we do this. To do this, we're going to be using here a component called bounds, and it's going to simply give us some kind of domain, and it's going to say, okay, so the distances are from 8.1 until 20.92. So these are like the distances that exist here. And now we're going to be using here the remap numbers component. Remap numbers are giving us the values from these distances, and we're setting the targets for them. And this is where we use the construct domain, and we say, okay, I want the domain from 9.99 until 29.9 to have the same kind of remapping. Here it is. So this is the target domain, and this is the domain that is going to be like a source domain. So this is the source domain, and the target domain is this. So remap all of these numbers from 8 to 20 in this way, from 9 to 29.9. So why are we doing this? Let's see. So now the result that we get are the numbers from 0 to 6 to 4. That's how many points we have. But you can see that they are in this domain from 9 until 29.9. You can see that there is no numbers that are less than 9.99 and bigger than 29.9. So that's what we want. And now what do we do with these numbers? So now for that we use graph mapper, and graph mapper is allowing us to have very smooth transitions when we use our extrusions. So in this case, these are going to be the values, and the domain are going to be from 0 to 1. So now we're remapping, because if you want to use graph mapper, you always want to have the remapping from 0 to 1. And for that, we need to use the range, and we need to use the list item. So we say here, okay, I have 624 distances, and I want them to be from the domain from 0 to 1. And that's where the graph mapper comes in handy. And once we remapped those numbers, then we're going to be multiplying it just to get the better extrusion values. And we're going to be using Z factor to get it extruded. So let me show you what this looks like. You see? So this pretty much means that the values that you see here are based on this curve. So for example, I can select this curve and I can move it. I can do something like this, and you will see that the whole structure will change. And that's what we want. We want the influence of this curve to help us to change the geometry. And that's what you're doing. Okay. And this graph is actually giving us this smooth transition between the elements. Okay. So now once we have that extruded, it's time to subtract some elements. So how do we subtract the elements? So in order to subtract the elements, we're going to be using one curve. And let me just show you what this curve is. So if you go to the top, you will see that this is the curve that I chose. So this is one curve that we're going to be using, which is around our site. This is the curve that will tell our algorithm to keep everything that's inside and to keep everything that is outside that we don't need. So in order to achieve this, we need a component called point in curve. And what this does, it actually evaluates if there is some curves inside that particular curve. So in this example, let me show you. This means that we want to keep everything, all the curves that are inside. So we want to keep all of these points, and we want to get rid of the rest. So we want to get rid of these. So in order to achieve this, we need something called larger than. So it's a mathematical operation. So what do we get here as a result? As a result, here we get zeros and ones and twos. So if you click here, you will see here that it says here 0 outside, 1 coincident, and 2 inside. This means that everything that is 0 is outside of this curve. Everything that is 1 is something that is exactly on the line, and everything that is 2 is inside. So in our case, we want to keep everything that is inside, which means everything that is bigger than number 1. In this case, this is number 2. So that's why we have here number 1. So we say here we want to have everything that is bigger than 1, and that's gonna be our result here. So you can see here that we have a total of 625 numbers, and here we have a total of 625 as well. However, you can see here that we have a Boolean operations. We have here true and false, true and false. So for example, what is it doing? It's saying, okay, 0 1 0 0 is saying, okay, is it 0 bigger than 1? The result is false, it's not. And then it's going one by one, and then it's saying 0 bigger than 1, false. And then when it comes to something that is 2, for example, let me check. For example, this one, 355. here, 355, true. Why? Because if 2 is bigger or greater than 1, then this is true. And that's why we get the true here. And this means that once we combine this with call pattern, the call pattern actually uses everything that is, it uses Boolean operations in order to exclude elements. And we simply give it a list here of all the centers. So these are like all the centers from these rectangles. So we say, okay, I want all the centers, and I want here the true and false from this guy, and that will give me the elements here. You can see how this is all green, and this means that I only want these elements. I don't want anything else. And that's pretty much what we did here. So now, once we came to that point, let me and yeah, I forgot to tell you here, you can also use a list of these extrusions. So not only the points, but also the extrusions, because the final file will be in extrusions. The final file will be a brep file, and not these middle points. So that's what we want. And now I'm gonna hide this guy, and I'm gonna go to the perspective, and I'm also gonna hide. Let me see. Oh yeah, we don't need this. We don't need this. Pretty much don't need all of this. Okay, so that's what we need. So what we did here, we pretty much said, okay, I want everything that is inside this curve, I want to keep, and that's what we did here. And now, this is very cool. This is really interesting aspect here. So now we need a second curve, which is the curve that is this one. If I go to the top, you will see this curve. Now I want to subtract everything that is inside here as well, but not from everything, but from this guy here. So how do we do this? So in order to get this right, first we need to see what we get out from here. So I put in the panel here to show you that what we get from this list here, we also get the points here, and we also get the open breps. And I intentionally did this so that I can show you one simple command that is very useful, which is called split tree, and also the parent viewer. So what does this mean? This means that this is your data that you got inside. So you got some points, as you can see, it has 3 coordinates, and then on the bottom, when you scroll down, you have a second branch, which is 0, 0. First branch is 0. Second branch is 0, 0, and then it has open breps. So how do you just select, for example, the breps? Because you don't need these points at all. Like you need to work with breps to continue with this definition. So in order to select only this branch, that's why you use this just to see, okay, there is 2 branches, and it's telling me, okay, this is branch number 1, this is branch number 2. And if you scroll, you can see this is that branch and this is this branch. So you can see that we actually want open breps. And that's why we use this split tree, and we use a mask. And what this mask does is it's telling me, it's saying, okay, I just want to select this particular branch. I just want to select, it's saying I just want to select this guy here. And that's why I have this as an input. So in case I want to select only the points, then I would change this simply to 0. And click OK. Now you can see the output that I got are just the points. It's all of those points, 173, 174. So if I want to select the second branch, I just come here and I click one more 0, and I click OK. Now I have breps, and that's pretty much how you do it. And now when we have these breps, this is the final result that we got. Let me show you. So I'm going to preview this. I'm going to hide this. And now we simply do the same thing all over again. This thing here. This is, so we search for the midpoints. These are the midpoints. We search for the point in curve. And this is our curve. And we also go, in this case, smaller than. And we get the result that looks something like this. And if you compare this to our geometry, that's pretty similar. It's not exactly perfect, but you get the idea of how this is possible. And now you can, of course, play around with these values here. You can see if you can, for example, increase here the height. You can manipulate this curve. And if you manipulate this curve, it will also change the the shape of the building there below. And one last thing we can do here, we can add gap holes, and that would be the end. You may notice that when we created a grid, we actually have some elements here that are missing, and this is intentional. So if you want to find out how you can actually fill them out and how you can have even better transition, you can join me on my Patreon page, and you can see the updated version of this definition there with all the project files as well. So hope that you like this video. Hope that you like the tutorial. If you have any questions or comments for me, please feel free to put them in the comment section below. If you found this valuable, please share it and like it. And until the next time, see you and take care.